As the world becomes more aware of the effect of our energy sources on the environment, countless scientists are searching for ways to use energy without leaving such a heavy carbon footprint. One idea being considered currently is the idea of using water's surface tension as an energy source. Water's molecules make the surface tension very unique. Water is made of two hydrogen atoms bonded to one oxygen atom, making the molecule very polar as oxygen's electronegativity is much greater than that of hydrogen. Because of these partial charges, water molecules are able to bond to each other to create a very stable surface. This surface tension is thought to be able to power small motors. A scientist named Andrei Sushko has been looking at the properties of water and ways the surface tension could be used for about 3 years, and won the Intel Science Talent Search in 2012 when he was 16 for his research. His experiment was a tiny motor, about 1/4 of an inch in diameter, that used surface tension to rotate. The motor's stator electrodes were converted in wax that caused the curvature of the surface tension and in turn caused the motor to rotate when an electrical potential was applied.
As explained before, the partial charges of water cause the molecules to bond to each other well. Because of the cohesive nature of water, it has a property known as surface tension. This property allows for water to resist an external force that is applied. As seen in the diagram, the cohesive forces between water molecules are shared with all of the neighboring water molecules. When a water molecule is completely surrounded by other water molecules, then the cohesive forces of all the neighboring molecules cancels out the force of that single molecule, and the net force is then equal to 0. This is, however, very different for a particle located on the surface of the liquid. Because there will be no cohesive force acting from above, the net force will be inward. As a result of this inward force, the molecules on the surface of the liquid will have a stronger bond than the rest of the molecules, and the surface of the liquid will resist being broken apart. The surface tension of a liquid is defined surface tension F divided by the length d in which the force acts. The SI unit of surface tension is Newton per meter. From this equation, we are able to deduce that as the distance in which the force acts increases, the surface tension of the liquid decreases. This idea is important to understand when thinking about ways in which the surface tension of a liquid could be made larger. While decreasing the surface area of water exposed to air increases the tension on the surface of the water, it decreases the available area for equipment that can extract the energy from the surface tension.
Scientists in Berkeley have created the world's smallest electric motor that has potential to power small devices that can swim, walk, crawl, and fly. It's still early to dictate what the motor will propel. It could possibly be used to deliver drugs in the body to fight disease, or propel nanobots that seek out explosives. Needless to say, it packs a big punch, even with its small frame. The motor is only 200 nanometers long. 1 nanometer is 1/billionth of a meter. However, its power density is 100 million times greater than the power density of a 225 horsepower V6 engine. The motor uses surface tension to power itself. As objects become smaller, surface tension becomes more and more important, and having it at the nanoscale would allow it to fully utilize its immense power. The motor is based on carbon nanotubes. Carbon nanotubes are hollow cylinders of pure carbon, approximately 10,000 times smaller than the diameter of a strand of human hair. The scientists at Berkeley Lab discovered a way to actually move indium particles along the tube, similar to an assembly line. This conveyor belt on the nanoscale can be pointed anywhere that scientists want to deliver mass atom by atom, making it a great nanoassembly tool. The team has now changed this belt into a tiny motor with incredible strength. The engine is built with 2 molten indium droplets, one bigger and one smaller. They are put side by side on a carbon nanotube. An electric current is sent through the tube, causing the individual indium atoms to move from the large to small droplet. The small droplet gets larger and larger until it touches the big droplet. After that, surface tension comes into play. In less than a nanosecond, every single one of the small droplet's atoms are moved to the large droplet, and the small droplet breaks up into nothing. After the small droplet collapses, the cycle begins again. The repetition, followed by collapse, mocks the speed and back-and-forth motion that most animals use to swim, run, and fly. The problems surrounding surface tension as an energy source revolve around the fact that it's fairly new. No one is quite sure if it would work for long periods of time, or how much energy could be produced with a motor. There is also the issue that as of now, no one knows if the energy could be continuous on a large scale or if surface tension would only be able to power things on a nanoscale. There is also the decrease of efficiency as the surface area increases. As surface area is more efficient on a smaller scale, to move it up and have it be used as a large-scale energy source may not be possible.
By using different solutions other than just water, we could possibly increase the energy output created by surface tension. As you can see, there are a variety of different liquids tested to measure how much energy is created. There is one liquid that creates more surface tension than any other: mercury. Is there a way we could naturally find mercury and use that to power the motors? If we were able to use mercury as a suitable substance, could it increase the longevity of the motor's motion? There seems to also be a slight increase in energy created between saltwater and freshwater. Even though the amount of energy produced doesn't seem so significant, that amount of energy can easily add up over a long period of time. This data suggests that if this were to be implemented into a large-scale project, we would be able to produce more energy by putting the motors by the coast and in saltwater lakes.
Another way in which the surface tension of water could be increased is by simply changing the temperature of the liquid. As seen in the graph, the surface tension of water decreases as the temperature of the liquid increases. This decrease is due to the fact that in general, the cohesive forces on a molecule decrease when the molecule is heated. As the temperature of the molecule increases, the energy of the molecule increases and the cohesive bond between the molecules decreases. All of this information combined suggests that the best place to extract energy from the surface tension of water would be on the coast or in saltwater lakes where the temperature of the water is not warm, for example, the Arctic or Antarctic oceans.
This new technique of utilizing water surface tension to produce energy is both innovative and potentially revolutionary. While there is a lot of potential for growth in this field of knowledge, there is a vast undertaking that needs to be done to harness the power that can potentially be had by utilizing surface tension as an energy source. If we are able to utilize this source of energy, it would not only be very powerful, but it would also be infinitely renewable.